Have you ever wondered what lies at the very edge of reality? What happens when the laws of physics as we know them are pushed to their absolute limit and then broken? We look up at the night sky, a vast canvas of stars and galaxies, each a testament to the immense forces that govern our universe, but hidden within this cosmic tapestry are objects of such profound mystery that they challenge our very understanding of space and time. These are black holes. They are not empty spaces, but rather the opposite. A black hole is an incredible amount of matter, a dead star perhaps, crushed into an impossibly small point by its own gravity. It is a place of infinite density. Imagine taking a star many times more massive than our own sun and squeezing it down. Squeezing it until it is smaller than a city, smaller than a house, smaller even than a grain of sand. The result would be a gravitational field so powerful that it warps the very fabric of space-time around it. This warping is so extreme that nothing, not even light, the fastest thing in the universe, can escape its pull once it crosses a certain boundary. This boundary is called the event horizon. It's not a physical surface you could touch, but rather, a point of no return. A one-way door into the unknown, from which no information can ever get back out. The idea of a black hole is a direct consequence of Einstein's theory of general relativity. Einstein showed us that gravity is not a force pulling objects together, but rather a curvature of space-time caused by mass and energy. A planet orbits the sun because it is following a straight path through the curved space created by the sun's immense mass. Let's imagine you are an intrepid astronaut journeying in your spaceship towards a stellar mass black hole, one just a few times the mass of our sun. From a safe distance, you would feel nothing unusual. The black hole would obey the same laws of gravity as any other object of the same mass. You could orbit it just as our Earth orbits the sun, perfectly stable and safe, watching the strange lensing of starlight behind it. The danger is not its existence, but its proximity. The closer you venture, the more pronounced its gravitational influence becomes. It's a very peculiar kind of pull. As your ship drifts closer to the event horizon, you would notice strange tidal forces starting to take hold. Gravity gets stronger the closer you are to an object. For something as compact as a black hole, the difference in pull on your feet compared to your head would become immense even from thousands of kilometers away. Your body would start to be stretched. It wouldn't be a sudden, violent event at first, but a persistent and growing tension. The part of you closer to the black hole is pulled more strongly than the part farther away. This differential pull is what would begin your unfortunate transformation. This stretching process has a vivid and descriptive name: spaghettification. It is precisely what it sounds like. The tidal forces would become so powerful that they would stretch you out into a long, thin strand of atoms, like a piece of spaghetti. Once you cross the event horizon of that supermassive black hole, your fate is sealed. You are now inside the black hole, and escape is impossible. It's not a matter of having a powerful enough rocket. The very nature of space-time itself has changed around you. Inside the event horizon, all possible paths, every direction you could possibly move, lead towards one place: the central singularity. The future itself points towards the center. Trying to fly away from the singularity would be like trying to travel back in time here on Earth. The flow of space is faster than the speed of light, pulling you inward relentlessly. From your perspective as you fall, the universe outside would appear to speed up dramatically. Due to the extreme effects of gravitational time dilation, time for you would slow down relative to a distant observer. If you could look back out, you would see the entire future history of the universe flash before your eyes in an instant. For an observer watching you from a safe distance, however, your fate would look very different. They would see your image slow down as you approached the event horizon, becoming redder and dimmer until you appeared to freeze at the edge, fading away over an infinite amount of time. Your personal journey continues, however. So, is it possible to survive? Based on everything we know from Einstein's theories, the answer is a clear and unequivocal no. The laws of physics dictate that falling into a black hole is a one-way trip to oblivion. The singularity is not a place you can visit, it is the end of time itself. The forces involved are so fundamental to the structure of space-time that no material, no technology we can possibly imagine could withstand them. Survival is simply not a part of the equation. The black hole will inevitably unmake you. However, science is always pushing the boundaries, and some theoretical physicists have pondered more exotic outcomes. Some ideas, stemming from the strange world of quantum mechanics, suggest that the information about what falls into a black hole might not be completely destroyed. One speculative concept is that a black hole could be a gateway, a wormhole, connecting to another part of our universe or even to another universe entirely. In this scenario, the singularity is avoided, and you would instead emerge somewhere else, although you would likely not survive the journey in any recognizable form. These ideas remain firmly in the realm of speculation,